So today we are using how we can use the D operator method for second order linear differential equation with constant coefficient. So we have been already proved the D operator, and also we solved some questions on first order linear differential equation from our previous video. So here today we are talking about the second order linear differential equation. So this is the question: my y prime prime minus 3y prime plus 2y is equal to e exponent 2x. So this is the form that is a linear second order with constant coefficient differential equation. So all that we tend to do is that wherever we see my y prime prime, that the second order is the same thing as the d square. So the d square here, that the d operator square, is the same thing as y prime prime. Wherever I see d, is the same thing as y prime, and wherever I see y is d exponent 0, because d exponent 0 is 1. Yeah, so to just make this substitution here. So my d square, that's the y prime prime, becomes my d square minus 3, and my y prime becomes my d, plus the 2 and the y here is d exponent 0. So d exponent 0 is 1. So we are going to get 2 times 1, which is 2. Or operating on a dependent variable y should be equal to e exponent 2x. Remember, here is a quadratic equation. Yeah, so you just find or factorize two numbers when multiply, you get 2, and that get minus 3. You are going to get d minus 2 multiplying d minus 1, or operating on y should be equal to e exponent 2x. So here we have two roots, that's d minus 2, which is equal to e exponent 2x. Then also we have d minus 1, which is also equal to e exponent 2x. So the whole of these roots is equal to e exponent 2x. So it means that what this one tells us that anytime I take one of the roots and I operate it on the y, it should give me a certain variable, a certain constant z, and that z, to whenever I choose the other root, here the other root is d minus 2, and I operate it on the z for the first one I did, then it should give me e exponent 2x. So that's what this means. So it means that anytime we take, so you can take your d minus 2, then you operate it on y, then you equate it to z. Then after that, you take your d minus 1, then you operate it on z. It should be called d exponent 2s. It's the same thing. You get the answer. So here I chose my d minus 1 and I operated it on y. So when I operate my d minus 1 on y, then it should give me a certain constant z. Okay, so also when I take the other one, which is d minus 2, and I operate it on the z, it should give me e exponent 2x. So that's the two assumptions we made here, this and this. So this will help us to find the z. Then after that, we make a substitution for the z here, then we find the value of y. That's all. So that's all that we intend to do in D operator method. We just find my z here, then whatever answer I'll get, I'll just make a substitution here, then I will make the y the subject, and I'll operate it on the z, then I get the answer. So let's see, how can we find the value of z? We just make z the subject from this place, this equation. So I'm going to get 1 over d minus 2 operating on e exponent 2x. So we compare to this general form. So z is equal to 1 over d minus a constant a operating on r of x. So just notice this. So here my constant here is the 2. A is 2. And the r of x is equal to e exponent 2x. So by comparing, you are good to go. So after that, you know that I've already written this part, that my z is equal to 1 over d minus a multiplying r of x. So that's what I have done here. My 1 over d minus a operating on r of x should be equal to e exponent ax. That's the first positive value of the a. Then we integrate the e exponent, then we write the negative of the a, so negative ax, and times r of x dx. Remember, I have already proved this equation for the operator method. So always keep this one in mind. Yeah, I've already proved it from our previous equation. So that's what we are applying here. So here, this my constant, that's the a. So minus 2, that's the a. So a is 2, a is 2. There's a negative. Okay, so when I operate it on the r of x, the r of x is e exponent 2x. Remember, I've said it here that my e of x, that's the r of x. R of x is equal to e of x when we compare. Okay, so that's what I did it here. So here my r of x is e exponent 2x. So you first write the positive of the e exponent 2x. You are going to get e exponent as, that's the positive value, so plus 2x. Integral of, then you write the negative of the 2. So integral of, that's how here we had the negative of them. So first you write the positive, that's the positive constant, then you write the negative constant. So negative constant, here the constant is 2, so negative 2x. Then here r of x is e exponent 2x dx. Okay. So e exponent 2x multiplying e exponent 2x, you are going to get e exponent 0, and e exponent 0 is 1. So we are going to get only dx. So e exponent 2x multiply integral of dx. Anytime you integrate dx, you are going to get x plus c. Okay. Okay, so you are going to get e exponent 2x multiplying x plus c. So this is z. This is the value for z. Now, I know my value for z. So that's what I was saying. Now you know the value of z. So you can just make a substitution for your z. So for whatever value we have, we make it here. So we make we make y the subject from this place. Okay. So we are going to get, you know that my r of x is e exponent 2x, as I said here. That's the r of x. Now r of x here, the whole of this place here is z. You know that z minus 1 bracket close multiplying. So this is 1 or 1. Okay, this is 1. Let me erase this place. So here is 1. D minus 1 y. Okay, so what we are intending to show, d minus 1 y. So just make y the subject here. So I'm going to get y is equal to 1 over d minus 1 operating on the z. And we've already find the z to be e exponent 2x plus x plus c. So that's the z. So we compare it again with our form y equals 1 over d minus a operating on r of x. So by comparing this, I can say my r of x here is the same thing as e exponent 2x multiply x plus c bracket close. So this r of x is the same thing as this. Okay, so quickly we try to write it again as we did previously. Okay, so here the whole of this is my r of x. You get it? The whole of this is my r of x, as we've already said. Okay, so here is what we intend to do is that first I will just write e exponent the positive value. So e exponent positive value. So the positive value of the constant 1. So it's positive 1x, so which is x. Then we write e exponent the negative of the constant. That's negative 1. You have to get negative 1x. Then we multiply it by the r of x. Now the r of x is the whole of this, which is e exponent 2x multiply x plus c bracket close bracket of dx. Okay, so this what I did here, that was what I wrote here. Yeah, this just that's the constant, the positive of the constant and the minus of the constant. So that's what I did here. Okay, So that's what I've done here. Okay. So we just try to multiply through by. So you see, this e exponent 2x is multiplying x plus c. So when you multiply e exponent 2x by x, you are going to get x e exponent 2x plus. Then you multiply c by e exponent 2, you are going to get c1. So it's a constant. Remember, because it is a second order differential equation, you are going to get two constants. So I just represented this c by c1. So when you multiply e exponent 2x by c, you are going to get c1 e exponent 2x dx. Okay. So after that, you know that e exponent minus x is multiplying through the whole of this. So we multiply e exponent minus x through by this. We multiply e exponent minus x by x e exponent 2x. So we are going to get x will be maintained. E exponent minus x times e exponent 2x. So we are going to get e exponent x, because the minus x plus 2x are going to get x plus. Then when you multiply e exponent minus x by c1 e exponent 2x, the 2x is going to add with the minus x. So I'm going to get c1 e exponent x all dx. Okay. Then here e exponent x is multiplying the integral of the whole of this. So we try to integrate this one separate. So we integrate the first part, which is the x e exponent minus x dx, plus then we integrate the other part, which is the c1 e exponent x dx. So here we can clearly see that this integration is by parts, because this is a certain function, say a linear function x multiplying another transcendental function, or simply exponential function. So this exponential function, this is a function. So it's a function, two functions multiplying, so by parts. So this is what I do, my integral by parts is the shortcut I used to do. So I always find the u to be the one which approaches zero easily when I differentiate. And comparing x and e exponent x, x approaches zero when I differentiate easily. So my u become my x, and my dv become the other part, which is the e exponent x. So you differentiate x once, you're going to get 1. When you integrate 1, a constant, you're going to get 0. Then I constant, so I'll differentiate until I get 0. Then I'll consider the right hand side, that's the dividend. Here too, when you integrate e exponent x, you're going to get e exponent x. You integrate e exponent x again, you're going to get e exponent x. So you do it until it's aligned with the 0. Then after that, you multiply it diagonally by here is plus, minus, that way. So positive x times e exponent, you're going to get x e exponent x. Then minus 1 times e exponent x, you're going to get minus e exponent x. Then when you integrate c1 e exponent x to, you are going to get c1 e exponent x plus c2. So the answer for this is this, and the answer for this is this c1 e x plus c2. So I just add them. So the e exponent x, that was the outside, will come. Then now the integral of this, so this is the e exponent x, which was outside, and the integral to, I had this. So the e exponent x will multiply the whole of this. So when e exponent x multiply x e exponent x, the x is maintained. E exponent x times e exponent x, you are going to get e exponent 2x minus e exponent x times e exponent x, you are going to get e exponent 2x plus e exponent x times e exponent x, c1 e, so c1 will maintain. Then e exponent x times e exponent, you are going to get e exponent 2x plus the c2 will come. Then e exponent x multiplying c2, you are going to get e exponent x. So I know that this e exponent 2x and e exponent 2x are similar or the same, a function e exponent 2x, e exponent 2x, but there's a constant, and these two, there's a constant here which is 1. So I can treat the whole of this as one function. So I can write it as negative of a constant or positive of the constant. So I first consider the negative of the constant, because this is a constant, this is a constant. I don't know whether when I add the two constants to give me a positive or negative. A constant, it could be positive or negative. So I choose the negative of the C1. Then I choose one of the E exponent 2x as E exponent 2x. Then plus C2 E exponent x. So this become my final answer. That's y is equal to x e exponent 2x minus c1 e exponent 2x plus c2 e exponent x. Then someone to can say, oh, my C1, I can make my C1 to be A. It's arbitrary constant, so it doesn't matter. So yeah, C2 to be B. So this is the negative sign. That's the negative sign. Or because this is a constant and this is a constant, we choose the negative of the constant. Someone who can choose the positive of the constant. So you can get this. So whether this or this, you are right. Okay. Thank you.